Hi guys! This video is the first part of our 5th live session on the SoccerNet-v2 challenge. We had the great pleasure to have a presentation given by our colleague Meisam on our replay grounding task with extra details and useful code explanations.
Feel free to join us for our last live session on Thursday the 27th of May at 1 p.m. UTC. We will examine the leaderboard just a few days before the end of the challenge. We will give information about the report that you must write to be eligible for a prize, and we will have some concluding remarks. This will also be your chance to ask questions or discuss ideas, as we will leave most of the time for Q&A. All the links are in the description below. Don't forget to subscribe to this channel to support us and enjoy!
Meisam received a bachelor and master degree in electronic engineering and communication systems at BASU and KT University of Technology, respectively. He co-founded a company and worked in the automation area with focus on computer vision for 2 years. Recently, he has contributed in several international collaborations. He is interested in image and video understanding, especially using machine learning techniques. Meisam is part of our amazing SoccerNet-v2 team. He spent quite some time with the replay grounding task, which he will now present to you. Meisam, it's your turn.
I'm glad to be here with you to speak about replay grounding, especially the baseline that we introduced in the SoccerNet-v2 paper. Let's look at what we are presenting today. I will speak about the definition of the replay grounding task first, and then I will introduce the baseline that we had in the paper. Then we see what's going on in the challenge, the leaderboard of the challenge. We watch the video that produced by Anthony that will help us actually to understand the model better. And after that, I will give you a short introduction to the codes from our dev kit. And at the end, we have some actually answer the question and have discussion. Actually, we have time. So what is replay grounding? Formally, you can say that the task consists in retrieving the timestamp of the action shown in a given replay shot within the whole game. But let's say it's much simpler. Imagine you have a replay and you want to actually find the real-time correspondent of that replay. By real-time, I mean not replay, in the broadcast video. So somehow you are grounding the replay to a moment in the broadcast video. And then another question comes up, how we can do this task, how we can ground a replay. Absolutely, there will be different approaches for actually responding to this task, but one solution that we selected for our baseline is projecting the replay grounding to action spotting view. Actually, if you look at this area, we have an action here, and we have the exact action, actually that action here. And but there are some differences. It is shown from different view. The length may be different, and for some cases we have different frame rate. Actually, the speed of the actually frames are different. But we can use some similarities between these two to actually ground this replay to the real-time moment on the broadcast video. And that's why actually we came up with a time is the approach that I actually showed here. And generally has 3 different phases and maybe a last phase actually of outputs. But in the phase 1, that is the data loading part, you can do different approaches. You can select different approaches, and for example, how you select a pair of replay clip and video chunk, how you actually make them having the same size and different things that you can work on. And I think it can be really interesting and it will be very helpful to having better performance working on this phase. And then, for example, when you prepare this, you pass the data to the model. And actually, for example, we use here the model that are designed for action spotting. That is why actually I say that we are projected the replay ground into action spotting view. And the last part will be the feature fusion. When you actually have the features, you want to fuse them in a way, and it will be actually another part that you can work on. You can use different structures here to make your network better and actually have better performance. We had different baselines using changing, for example, some part of data loading model and fusion part named calf. Calf more negative, net will add more negative, and this time more negative come from approach, let's say a negative mining approach that we added to our data loading and produce new, for example, baseline after calf. Let's speak about the calf method. Calf method is based on the calf network that Anthony and other colleagues actually suggested in their paper, a context-aware loss function for action spotting in soccer videos. And as you can see, we have here a pair of replay clip and video chunk that are fed to a model. And here the weights are shared. But I have to say in our training, this part is not trainable because we are using the ResNet or I3D feature, but this part is the temporal CNN that actually temporally convolves our features are trainable, and you can actually fine tune the features as well, and I think it will be very helpful if you do this. And after having the features, we can concatenate replay features, come from here, and video chunk features together and pass it to the rest of the network. Is the same with some minor changes. For example, since we don't care about the classes, we remove the class part. If you want to know more detail about the calf structure, you can go back and watch the tutorial 2, I think. There, Anthony and Adrien actually describe this method completely. And so finally we came up with a timestamp, and that shows, for example, where the action happens in the video chunk and the confidence of that timestamp. I want to say a bit more about the data loading part that we use. For each replay, we have to say we have a positive sample if the action is shown. For some rare cases, the action is not shown and we just see the replay. But for most cases, we have a positive sample with each replay. And there are many negative samples from other classes. You can select, actually, you have a wide variety of choose here, and at least some negative sample from the same class. And in this data loading part, we select just one video chunk, actually paired with the replay, but by chance, and the probability of actually being a positive sample is 0.5, and it can be random negative or hard negative with a probability of 0.25. Another thing that actually have to be considered here is that for the most cases, replays are shorter than video chunk. And for example, in our case, we selected 60 seconds for our video chunk. And in this case, we repeat the replay until getting the same size as we were trying to here have the fixed size that will be fed to the segmentation module and grounding module and that. And after the training, we actually had the average AP result, average AP. That is the same metric, but with one difference. Instead of actually, because we don't have any classes here, we just have one class. Instead of MAP, we have AP, and actually we reached to 32.3 for the test set and 31.3 for the challenge set. But we mentioned here negative and hard negative. Let's speak about it with a bit more detail. As you can see in this picture, for example, we have a replay of a goal, and this is the correspondent moment of that goal in the real-time broadcast. But there are some other goals that actually are negative sample, but are in the same class. And as you can see, it is actually reasonable that it is harder for the network to differentiate between, for example, this negative rather than other negative that are from other classes like fall or short or something else. So that's actually give us this idea we can work on, give more attention to this actually hard negatives. And we actually did a negative mining and added a negative mining part to our data loading to the previous baseline and came up with another baseline that we call it CALF more negative. And instead of having one chunk for each replay, we we have 5 actually video chunk that actually one of them is positive and 2 of them are random negative from other classes and 2 of them are hard negative if there is actually, for example, 2 chunks. And you can see here by actually by applying this negative mining, we the performance improved considerably from 32.3 to 41.8, and the same, approximately the same for the challenge. And I think it can give you actually some ideas if you want to work, and you can work, for example, in this area, maybe try another actually structures playing with the data loading part. And another actually baseline is NetVLAD based model. Actually, we are using, in the model part, we are using NetVLAD, and NetVLAD actually, if you want more detail about NetVLAD, you can, I think, watch the tutorial that's presented by Silvio about NetVLAD++, but I think there were good material about NetVLAD structure. And we trained the model. The data loading part was the same as CALF more negative, but we have a fusion part was a bit different. Instead of concatenating features and passing them to some layers, we use cosine similarity and then some layer for predicting the confidence. And for having actually for producing the regression, for predicting the regression, we use the features of video chunk directly, and actually that give us the final result. And we trained the model, and we reached to 22.75 for the test set and 25.13 for the challenge set. And although the results are not really competitive, for example, with the CALF more negative, but this doesn't actually imply that NetVLAD is not really good for this work, because I think maybe the structure is not very compatible with the NetVLAD actually pooling. And one suggestion would be actually using NetVLAD++ and maybe changing some of this structure to have a better or more compatible actually network. And I think it will be actually it will give you a good result if you are interested. And so generally you can see the result of our baseline, and we tried it for different video chunk sites, and as you can see, this 60 seconds was the best generally for actually all three baselines. And well, let's see the leaderboard of our challenge. These days, I think the replay grounding is really competitive. Like action spotting, we have a really good performance by visual analysis of human group, and two other private submissions that are actually have competitive results as well. And I think that this result will be absolutely better in the next week. And let's see a video that Anthony produced. Thank you, Anthony. That showed actually, I think, the CALF more negative model, how actually detect. So here you can see a replay of a goal, and this is a true positive actually of that replay that is truly grounded. But there are some false positive. Other goals are grounded falsely. For example, that was the first. This is the second one. And but if we look at them simultaneously, we can see that there are some similarities. For example, they have a pass to the penalty point. There is a stop and a single touch and shoot, and then goal and the actually close-up view of the player. And that shows that the network actually look at the set of actually actions. Absolutely, it is two of them are wrongly grounded, but it can be really inspiring for actually how we can make the model more robust to these similarities. And so we actually defined the replay grounding in the conclusion, and we introduced our Siamese-based baseline and checked what's going on the leaderboard on challenge. I will actually go to the code if there is no question. So this is our dev kit, and you can see the replay grounding task 3. Actually, you can go there. This is some introduction and some material that show you what's going on, how you can generally getting started here, and this is our baseline. But the thing that I wanted to emphasize, because there is a bit tricky and not very clear, is evaluation on the challenge set, because the replay grounding task actually in this task you have to know the position of replay, and in the challenge set, because you don't have the label, our code use the label for training, for validation and test set to find the replay, but because you don't have the label for challenge set, you need some auxiliary annotations, and you can download it manually from here, and you have to unzip it in the same directory that you have other labels and features. And I will tell you how you can actually use the evaluation on the challenge set. Let's go to the code actually, for example, for the CAF more negative. Here you can see we have different parts for example, the main part of last data set model. First of all, you need to actually create, activate, install, or update the requirements package that are exactly the same as actually you did for action spotting. And then for the training, actually, you can simply just use the main function, the main file, and then pass some parameters like the SoccerNet path, the path that you save your data, the data set there, and the name of features, the model name, the model actual name, and the evaluation frequency, the chunk size. And this is the loop, for example, here that actually refer to number of chunk with each replay. You can change this to another number, maybe 10, 8, any number you want. But if you have enough actually GPU and you don't have any problem for computation actually power. And you can actually save the results by passing the detection path, the folder that you want to save the result, and passing this flag that you say to the model to save the result for you. And also, as you can see here, we have actually weights of our model. You can use this actually by actually passing the name of the model and the test only parameter, and you can get the same result as we had in the in our paper. Or you can actually use the reload the weights of your model by passing the name here and seeing actually predicting the results for challenge set and sending that to eval AI. And in the last part for the challenge, actually, if you want to predict the result of challenge, you have to send the challenge parameter. And you have to be actually aware of that because you don't have access to the label. You cannot actually compute the performance locally. And if you pass the challenge parameter and update your SoccerNet package, it will disregard this and it will just pass you some -1, I think, and just produce the result for you, and you can actually submit them in the eval AI server. As you can see here, for example, this is a data set, and it shows that how we load our data. For example, here we find all the replays. Then in the get item, we actually came up, for example, for each replay, we go to load the positive chunk, negative chunk from the same class or from the actually other classes randomly will be selected. You can actually go to this file and change every parameter that you want and see what's going on, how you can reach better performance. And the other part could be the model that our model is here. This is, for example, the temporal convolution layer. This is the temporal module here, the segmentation module, the detection module. You can change each part, actually add another part, remove some of the part that you want, and customize the network for yourself. And there are other parts, and for example, you can go to the loss, and this is the context-aware loss here. But for example, I was thinking that if you remember, for the context-aware loss, we had 5 different far before, after, and far after. And since actually in the work they didn't want to penalize the network because of predicting, they make the loss of before to 0, but for replay grounding it can be something like after, because before is as precise as actually worthwhile after in this case, and you can, for example, mirror that, and maybe it will improve the result. And so that's it. Actually, that was a short intro in our actual baseline. Actually, to the guys that are watching this replay, please, if you have a question, just write it as a comment in the actually below actually.
So thank you guys, and so next week we will have a final live session about concluding remarks and a few tips, and have a look at the leaderboard and see what people need to write as reports, give a few details, and having a Q&A session in case people have questions. Otherwise, well, that's it for today. So thank you very much and see you soon.